Okay, section 11.5, the instructions on all the problems will say something like completely factor. And one thing I want to point out about that, anytime you're asked to factor something, make sure the first thing you do is check for a greatest common factor. Something that maybe is common, maybe you can take an X out of everything, maybe you can take a 2 out of everything, something like that. We'll go over a few examples where we do that. But make sure anytime you see that word factor, you look for a greatest common factor first. The next thing is binomials. You probably know these are two-term polynomials. And with binomials, if we're asked to factor, there's only 3 ways to factor. The first way to factor, and this is binomials again. Only 3 ways to factor binomials. The first is difference of squares, and I'll talk about on the next slide what squares are. Difference, of course, is subtraction. 2, difference of cubes, and I'll talk about cubes in just a second. And then the last one is sum of cubes. So sum is addition, and it's surrounded by 2 cubes. So this is just with binomials. If it was trinomials or something with 4 terms, we wouldn't worry about the difference of squares, difference of cubes, or sum of cubes. So next I'll explain what a square is. These are numbers that can be made by squaring something. So sort of the thinking is 1 squared, 2 squared, 3 squared, and so on. This is just how squares are constructed. So 1 squared, 1 times 1 is 1, 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. And really, probably that would be a long enough list, maybe 144, 11 squared, or 12 squared rather. And you might make a list like that, just a reference. And we also have square variables. X squared is a square, x to the 4th, x to the 6th. And you might notice a pattern with the variables, 2, 4, 6, and then so on. With cubes, the same sort of idea, 1 cubed, 2 cubed, 3 cubed. This is how we identify a cube. So 1 cubed, 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 cubed, 5 cubed, 6 cubed, 7 cubed, and then so on. Really, you don't need as long a list of cubes because the examples that you'll see will mostly be limited to just the first 4, 1, 8, 27, and 64. Those are the ones that you'll see most often. As far as cube variables go, x to the 3rd, x to the 6th, and there's a pattern there also. 3, 6, the next one would be x to the 9th. Those are all cubes, and then so on, 12, 15, 18. So if we say the difference of squares, then we're talking about 2 things that are squares with a minus in between. If we're talking about the difference of cubes, we're talking about something over here that's got a minus in the middle. So 125 minus x to the 3rd. Both of those are cubes, and with a minus in between, it would be a difference of cubes. Okay, so we'll look at our first example. 25y squared minus 16x squared. So this section will have some binomials, it'll have some trinomials, it'll have some where there's 4 terms. So you'll want to note that it's a binomial, and keep in mind there's only 3 ways that you can factor this. Is it difference? Actually, let's go back. the instructions will say completely factor, and you do want to take a second. This will be easy to forget because most of the time there won't be anything that you can take out, but you do want to check to see if there's a greatest common factor. If we look at these numbers, 25 and 16, 5 goes into 25, but 5 doesn't go into 16. 25 doesn't go into both. We can't take X out of both of them. We can't take Y out of both of them. So in this case, and in most cases, there won't be anything that you can take out. No greatest common factor. But it is a binomial. So we'll check to see if it's difference of squares, difference of cubes, or maybe sum of cubes. So hopefully you've got a reference while you're doing these problems, a reference of squares, a reference of cubes, just so you can just look straight over. And if we're checking these out, I can go ahead and mark off sum right off the bat because we've got a minus in the middle. So at most, this is a difference of something. So it could be difference of squares. It could be difference of cubes. 25, if you look at your squares list, 25 is a square. 16 is also a square. Y squared and X squared, they both have an exponent of 2. So if it's an even exponent, then the variable is a square. So this one is the difference of squares. And the formula for this is A minus B, A plus B. And in this case, A is going to be the square root of the first one. So the square root of this first term. The square root of 25 is 5, since 5 times 5 makes 25. The square root of y squared is y, since y times y makes y squared. So A, the square root of the first. B is going to be the square root of this second term. Square root of 16, hopefully you know, is 4. And then the square root of x squared is x. So as long as you can come up with A and B, then filling in this formula should be pretty easy. A minus B, and then A plus B. Next example, number 2, 8x squared minus 2y squared. The instructions, if it ever says factor anywhere, so completely factor the given polynomial, that word factor is in there, so we want to remember to check for greatest common factor. And if we look at these, can't take x out of both, can't take y out of both, but 8 and 2 both have a factor of 2. So we're going to take out that 2, and then we're going to rewrite. Basically what you're doing is dividing by 2. So 8 divided by 2 leaves us with 4. We didn't take any x's out. 2 divided by 2 leaves 1. And we didn't take any y's out. So we got y squared. And anytime we've got 1 in front of a variable, we don't need the 1. So that's the first step. Inside that parentheses, we've got a binomial that we might be able to factor. So we want to check difference of squares, difference of cubes, or sum of cubes. It's definitely not sum of anything. And if you look at the numbers, 4 is a square, x squared is a square, and y squared is a square. So this one is difference of squares. So again, a minus b, a plus b. A is going to be the square root of the first term. Square root of 4 is 2. Square root of x squared is x. And then b is going to be the square root of the second term. Square root of y squared is just y. So we're going to continue bringing down the 2, but when we factor the difference of squares, we've got a minus b, and then a plus b. Be careful that when you do the difference of squares part that you don't forget that 2 that we took out. Number 3, gonna factor 1 plus 4x squared. So it does say factor, so we want to check greatest common factor first. Can't take x out of both. 1 and 4 don't have anything in common other than 1, and we don't do anything with 1. Next, it's a binomial. It's got 2 terms, so we know it's a binomial. And you want to check, is it difference of squares? Well, it's not difference of anything because we've got a plus in the middle. Difference of cubes or sum of cubes. Could be sum because it is a plus in the middle. And if we look at the cubes part though, if you've got your cubes list, 1 is on the cubes list, but 4 and x squared are not on the cubes list, so this fails the cubes part. So this one, if it's not any of these 3, it's not factorable. Binomials, only 3 ways to factor them. If it's not one of those 3, not factorable. (180x to the third minus 125x). Greatest common factor. Hopefully you notice on both of these we've got an x, so we could take out an x to start with. Also 180 and 125 both have a factor of 5 that we can take out. And remember, we're dividing, so when you take out that common factor, that 5, 180 divided by 5 leaves 36. We took out an x that we had to take out of both of those, and then that leaves 2 x's on that first term. We divided this by 5, so that leaves negative 25, and we took out the x, so there's no x's left. So done the greatest common factor. Now we want to notice there's a binomial in that parentheses. So we want to check, is it difference of squares, difference of cubes, or sum of cubes? Definitely not sum of anything. We've got a minus in the middle, but it could be difference of squares or difference of cubes. If you look at your squares list, you'll see that 36 and x squared are on there. Also 25 is on there. So difference of squares was a minus b, a plus b. A in this case, the square root of the first term in the binomial, square root of 36 is 6. Square root of x squared is x. And then b is the square root of the second term. Square root of 25 is 5. So bring down the 5x, and then we'll do the a minus b, and then a plus b. Number 5, 8y cubed plus 27. Completely factor the given polynomial. So greatest common factor is the first thing that we check. Can't take y out of both of them. 8 and 27 don't have anything in common. 2 goes into 8, but it doesn't go into 27. 4 doesn't go into both. 8 doesn't go into both. So no common factor. Does have 2 terms, so this is a binomial. So if it doesn't have a greatest common factor, then we just want to check these 3 things. If it's none of those, then we'll say it's not factorable. It's got a plus in the middle, so it's definitely not difference of anything. It could be sum of cubes. It's got a plus in the middle, so it's sum. Cubes, if you look at your cubes list, 8 is on there. Y or x to the third would be on there. 27 is also on there. So in this case, sum of cubes is what we're going to go with. And the formula for this is a plus b, and then a squared minus ab plus b squared. And by the way, a on difference of squares, a is the square root of the first one, b is the square root of the second one. Here we're talking about cubes, so this is the cube root of the first one. So a in this case, the cube root of 8 is 2, since 2 times 2 times 2 would make 8. And then the cube root of y to the third is just y, since y times y times y would make y to the third. B is the cube root of 27, which is 3. So as long as you can come up with A and B, filling in the formula is not really too bad. So I'll zoom in on part of this. So again, we're doing this formula, filling in A and B. So that's our first parentheses. That's our A plus B. And then you want to be careful on this A squared part because A is 2y. So we want to square both parts of that. We want to square the 2 and square the y in order to square A. So 2 squared is 4. Y squared is just y squared. And then we're going to subtract AB. AB is butted up against each other, so it means we're multiplying. A and B, we're multiplying 2y and 3. 2 times 3 is 6. And then on the end, we're adding b squared. So b is 3. If you square that, get 9. All right, next, number 6. Here we've got x squared plus 12x plus 32. Instructions will say factor, so you want to first check to see if there's a greatest common factor. Can't take x out of everything. 32 and 12 have something in common, but there's no number in front of x squared besides 1 that would have that common factor. So there's no common number, there's no common variable. So no greatest common factor. Second, it's not a binomial. Here we've got 3 terms. So we're not checking difference of squares, difference of cubes, sum of cubes, none of that stuff that we've done on the first 5 problems. is applicable here. It is a trinomial, 3 terms. So trinomials factor into 2 parentheses. Trinomials factor into 2 parentheses. And this is going to be important to be good at. Some of the things that we do are kind of one-offs, and they don't come up all that often, but factoring trinomials comes up a lot. When you take college algebra, factoring trinomials will come up a lot, and you want to be really, really good, especially with the more basic ones. So for this one, they're going to factor into 2 parentheses, and the thing that goes first in those parentheses has to multiply to be x squared. So 2 things that multiply to be x squared. Hopefully this is the easiest part, x and x. And the thing that goes last in both those parentheses multiplies to be the last term there. The trick here is if the coefficient of x squared is 1, and that is important here, it's 1. If it's 1, then you want 2 things that multiply to be 32 and then also add to be 12. So usually on the side, I'll write some things that multiply to be 32. And I usually start with 1. 1 times 32, 2 times 16. 3 doesn't go into 32. I'm just going up by 1 on the left side. 4 does. 4 times 8. 5 doesn't go into 32. 6 doesn't go into 32. 7 doesn't go into 32. And then you're back up to 8. So once you're back up, once you've rounded out to the right side, then you know you've got a comprehensive list. And we're just looking for a pair that can add to positive 12. Adds to 12. So positive 4 and positive 8 multiply to be positive 32 and then also add to 12. So positive 4 and positive 8. So again, like I said, that process there, this is just your sort of basic factoring a trinomial. You'll need to be really, really practiced at that. Number 7. X squared minus x minus 30. Again, the instructions say factor. Always remember to check for a greatest common factor. 9 times out of 10, there won't be anything to take out, but you do want to check. We can't take x out of everything, and then there's no number we can take out of everything. So no common factor. It is a trinomial. So those are going to factor into 2 parentheses. Keep in mind the first thing in both those parentheses has to multiply to be x squared, or whatever this first term is. X and x. And then the last thing in both of those has to multiply to be negative 30. So down here below, I'll go ahead and write negative 30. And then I'm gonna not include the sign on the factors, but we'll figure that out here in a minute. But 1 and 30, one of those would need to be negative. 2 and 15 multiply to be 30. 3 and 10. 4 doesn't go into 30. 5 and 6. And like I said on the last one, once you round around to the right side, so 1, 2, 3, 4, 5, 6, then you know you've got a comprehensive list. And we're looking for a pair in this case. Like I said before, if the number in front of x squared is 1, then you're looking for a pair that adds to the middle. So in this case, we're wanting one that adds to -1. Five and 6 can add to -1 if the 6 is negative. So we need a +5 and a -6. Number 8, 2x squared plus 18x plus 36. It won't say factor exactly. It'll say something like completely factor the given polynomial. But if we see that word factor, we want to check for greatest common factor. And in this case, we can't take x out of everything, but 2, 18, and 36, we can take a 2 out of those. So you'll want to take the 2, and before you do anything else, you want to divide everything by that. So 2 divided by 2 is 1 with the x squared. 18 divided by 2 is 9. We didn't take any x's out. And then 36 divided by 2 is 18. Second, we've got a trinomial inside that parentheses. So you want to factor that. That's going to factor into 2 parentheses. Be careful, because I see this a lot. Be careful that you don't forget that greatest common factor that you took out. First thing in that parentheses is going to multiply to be x squared. And again, since the number in front of x squared is 1, then we're going to be looking for 2 things that multiply to be 18 and then add to be 9. So on the side, I'll put 18 and we'll go through 1 and 18, 2 times 9, 3 times 6, 4 doesn't go into 18, 5 doesn't go into 18, and then we're back up to 6. So looking for a pair that adds to 9. 1 and 18 couldn't add to 9, 2 and 9 couldn't, but 3 and 6 can. Wanted to add to +9, so +3 and +6 multiplies to be +18 and also adds to 9. So +3 and +6. Number 9, 5x squared minus 31x plus 30. Put a little star next to this one. So the instructions will say factor. So first thing, greatest common factor. Can't take x out of everything. 5 and 30 have a common factor of 5, but 5 doesn't go into 31. So no common factor here. Second, it's a trinomial. But the reason I put the star there is I want you to notice that the number in front of x squared isn't 1. On the last couple examples we looked at, it was x squared by itself at the front with a 1 in front of it, an invisible 1. It's not 1 in front of x squared. So there's different ways to do this. I'm going to go ahead and use the AC method. AC method is where we multiply the first term, the first coefficient, and then the last. And what we're going to do is we're going to find some factors that we can replace the middle term with. So let me move part of this. So if we multiply these, 5 and positive 30, then we get positive 150. And we want to go through the factors of 150. So 1 and 150, 2 and 75, 3 and 50. 4 doesn't go in, 5 and 30. 6 and 25. And by the way, you can use your calculator on this and just do 150 divided by 1, 150 divided by 2, 150 divided by 3, 4, 5, 6. And 150, where are we at now? Divided by 7. Doesn't work out. 150 divided by 8. 150 divided by 9. 150 divided by 10. And then you can do 11, 12, 13, 14, and then back up to 15. We do have a pair that can add to negative 31, the 6 and 25, if they're both negative. Negative 6 and negative 25 multiplies to be positive 150, and it also adds to negative 31. So what we're going to do is we're just going to replace this middle term. The rest of it's going to stay the same. So it's still going to be 5x squared minus 6x minus 25x plus 30. Okay, and then what you want to do from there is we'll want to factor by grouping. So we're going to group off the first two and then group off the second two, and we'll factor by grouping. And this is a little bit more complicated example. You don't necessarily need to be an expert at this. It will come up, but it's the more basic one, like on number 9 or number 8 and number 7, that you will need to be really good at. But this one you'll want to practice for this section and for the few places where this kind of factoring trinomials does come up. But once you've got those pairings, you will want to look at these groups and say, what can we factor out? With the first pair, we can take an x out of both of those. The numbers don't have anything in common. So we'll go ahead and factor out an x. And then you want to write what's left. If you take an x out of the 5x squared, you're left with 5 and then 1x. If you take an x out of the negative 6x, you're left with negative 6. On the second pair, you'll want to notice it does start with a minus. So that's an indication that you'll want to take out a negative, whatever's in common. If you look at the 25x and the 30, we can't take x out of both. But 25 and 30 have a common factor of 5. So you'll just want to divide both of those terms by 5. 25 divided by 5 is 5, and we didn't take an x out. 30 divided by negative 5 is negative 6. And what will typically happen is you'll have part of that that's identical. The parentheses is the same, 5x minus 6. And we're going to take that out and then multiply it by whatever was left. So kind of a tricky process. We'll do another example of that. Number 10. 4r squared minus 31r minus 8. Greatest common factor. We can't take r out of everything. 4 and 8 have a common factor, but 31 doesn't. So no common factor there. Second, it's a trinomial. And I'll put a star next to this one because you'll want to notice it's not a 1 in front of x squared. So we're going to use the AC method, where we multiply the first and the last one, and we're going to replace the middle term. Make sure when you do this multiplication that you consider the sign. So 4 times negative 8 would give you negative 32. And then we're going to list out the factors of 32. One of them will need to be negative, but we can decide that later. So 1 and 32, 2 and 16, 3 doesn't go in, 4 and 8, 5 doesn't go in, 6 doesn't go in, 7 doesn't, and then we're back up to 8. So we want a pair that can add to be negative 31r. One and 32 could make negative 31 if the 32 is negative. So we're going to rewrite the whole thing, AC method again, 4r squared, and we're going to use positive 1r. Getting that from this here, 1 and negative 32. And then minus 8. Okay, and then next we're going to group and factor. So hopefully you can look at these pairs and say, oh, I can take r out of both of those. This one, I can take 8 out of both of those. Also, it starts with a negative here, so you want to factor out a negative 8. So we'll go ahead and do that. You can take r out of both of those first ones. If you take r out of 4r squared, you've got 4 and then just 1r. And if you take r out of 1r, you're left with just 1. And then on the second one, we're going to take out negative 8. Again, like I said, 8 is a factor of both of those, and you're taking out a negative. Negative 32 divided by negative 8 is 4, and we had that r that we didn't take out. And then negative 8 divided by negative 8 is positive 1. And like I mentioned before, you should end up with parentheses that are the same. So this is going to be 4r plus 1, and then times r minus 8. Number 11, 12n squared plus 60n minus 90. Okay, so can't take n out of both or all of them, but maybe you notice that they're all even for 1, so you could at least take out 2, but you do want to take out the greatest common factor. And 12, 60, and 90 have a common factor of 6. So if you go ahead and take out 6, and by the way, I'll just show this just to, hopefully everybody would notice that they're even. So let's say we took out a 2, just for instance. You don't necessarily have to write this down if you're copying the notes. But you would take out the 2 and then divide everything by 2. So you'd have 6n squared plus 30n minus 45. And then the way you'd know it's not that 2 wasn't the greatest common factor is that you still have a common factor inside. 6, 30, and 45 all have a common factor of 3. So if you took out that 3 and multiplied it with the 2, you'd actually end up with 6 on the outside. So let's go ahead and start with the greatest common factor, 6. And then divide then. So 12 divided by 6. We didn't take out any n's. 60 divided by 6. We didn't take out any n's, so we still have that in there. And then 90 divided by 6 is 15. And you could look at these here and say, oh, 2 and 10 have a common factor, which is 2, but 2 doesn't go into 15. Okay, next we've got a trinomial inside. And I do want to put a star on this one again because the number in front of n squared isn't 1. So in this one, we do the AC method, where we're going to multiply those and then rewrite the middle. And keep in mind, you do consider the sign. So it's not 2 times 15, it's 2 times negative 15, which would be negative 30. And then we'll list 1 times 30 makes 30, 2 times 15, 3 times 10, 4 doesn't go in, 5 times 6. One of these would need to be negative, but we're trying to make a positive 10 out of one of these. And in this case, if you're trying to add these, 1 and 30, if you add them, you could either make 31, or if one of them was negative, you could make 29. But we can't make 10 out of that. 2 and 15, if you added them, you could make 17. If you subtracted them, you could make 13, but not 10. 3 and 10, you could make 13. You could make 7, but not 10. 5 and 6, same thing. So none can add to 10. So in this case, and in some cases, you won't be able to factor the trinomial. But we did factor this whole thing a little bit because we were able to factor out a 6. So, so you'll stop there, and then this part would be your answer. Number 12, the rest of them will be a little bit easier. They're basically some stuff that we've sort of covered already. 7a cubed, and then 2x plus 5, plus 6x, and then 2x plus 5. So anytime they give you one of these with 2 terms with a parentheses, that 2x plus 5, this is very similar to what we did on number 9 and number 10. If you've got that common factor, 2x plus 5, you can take that out, and then you're just going to multiply it by whatever was left in front. So in this case, 7a cubed plus 6x. Done. So some of these hopefully will go pretty quickly. $13xy plus 2y minus 15x minus 30. Instructions will say factor. Greatest common factor. On the last one, by the way, the greatest common factor was that 2x plus 5. So we did take that out and then wrote what was left. Here, greatest common factor. Can't take x out of both. Can't take y out of everything. Numbers don't all have something in common. So no greatest common factor. This one now has got 4 terms. And we've sort of dealt with the 4-term ones before. These are the ones that we're going to factor. Let me do it like this. Factor by grouping. Factor by grouping. So if we group the first two, hopefully you notice we can take out a y. If we group the second pair, we can take out a 15. 15 is a factor of both of those. And then also we can take out a negative. So go ahead and do that. And take out y. Ooh. And then just looking at the first group, so take out a y, and then we're left with the x on the first term. Take a y out of the second one, and you're left with a 2. And here we can take out 15, and in this case, a negative 15. Then we're left with x. And if you take out negative 15 from negative 30, you're left with a positive 2. Negative 30 divided by negative 15, positive 2. Okay, one more. Number 14, 16p cubed plus 22p squared minus 8p minus 11. Factor 1, greatest common factor. Can't take p out of everything. 11 and 8 don't have anything in common. So no numbers that we can take out of all of them. Second, it's got 4 terms. So we're going to factor by grouping. So going to group the first 2. Going to group the last 2. And we'll factor them. So in the first pair, we can take out 2 p's. You can take a p squared out of that. You can also take p squared out of that. 16 and 22, we can take a 4 or 2 rather out of both of those. So 2, and then we can take out 2 p's. And we want to divide. 16 divided by 2 is 8. We took out 2 p's out of p cubed, so that leaves 1 p. 22 divided by 2 is 11. We took out both of the p's, so no p's left. On the second pair, the 8, we can't take p out of both. 8 and 11 have nothing in common, but they're both negative. Even if they weren't, we can still take out a negative if this first term is negative. So we'll go ahead and take out a negative 1. And all that does is that changes the signs of both the things. So instead of negative 8p, it's positive 8p. Instead of negative 11, it's positive 11. And that's it.